In this video, we are going to learn how to attempt the past paper of AP Chemistry year 2023 and FRQ questions. So first of all, they are saying manganese have several common oxidation state. Write the complete electron configuration for a manganese atom in the ground state. So manganese is basically Mn 25, and if it is manganese 25, that means its atomic number is 25 and there are 25 electrons that are present in it. So when we are going to write its electronic configuration, it is going to be 1s2, 2s2, 2p6, 3s2, and 3p6, 4s2, and 3d5. When manganese form cations means an electron has been removed from it. Electrons are lost from which subshell first. So electron will be lost from the outermost shell, and that is going to be 4s. So we are going to write 4s because when an electron has been lost, so it is going to be lost from 4s first. So the next question says a student performs an experiment to produce a manganese salt of an unknown composition MnXCl and determine its empirical formula. The student places a sample of manganese in a beaker containing excess HCl. So we have a beaker in which there is HCl and that is present in excess, and you are adding manganese. After adding manganese, it is going to form MnXCl. So this was the mass of empty beaker, this was the mass of beaker and Mn solid, and mass of beaker and MnXCl after heating to the constant mass. They are saying calculate the mass of chloride in the sample of MnXCl remaining in the beaker. So when we want to find out that how much mass of Cl would be there, so what we can do, this was the mass of manganese and the beaker, okay, and this is the mass when chloride has been formed. So this is second mass, this is going to be first mass. If we are going to subtract both of them, then we are going to have the mass of Cl. So that is going to be 62.673 minus 61.262, and that comes out to be 1.411 gram chloride. So then calculate the number of moles of chloride in the sample of MnXCl remaining in a beaker. So when we have to calculate the mass, what we have to calculate the moles. Simply mole is equal to mass over mr. Mass is how much? 1.411. mr is 35.45, and that comes out to be 0.03980 mole of Cl. The student determines that 0.0199 mole of Mn was used in the experiment. So you have Mn and you have Cl, and you need to find the empirical formula. Mole of Mn has been given to you 0.0199. Chloride is 0.03980. You are going to divide with the least number of moles, that is going to be 0.0199. Over there is also 0.0199. It comes out to be 1:2. So Mn is having 1 and Cl is having 2. This is going to be the empirical formula. The student repeats the experiment using the same amount of Mn and HCl and notice that some of MnXCl splatters out of beaker as it is heated to dryness. Will the number of moles of chloride calculated for this trial be greater than, less than, or equal to the number calculated in part C? So, as the mass of MnXCl is lost due to splattering, the final mass of MnXCl will be decreased. So, there'll be, you can say, the less number of moles of chloride would be present in them. So, how we can write them? So, this is going to be the right explanation that the number of moles will be less than, because as some mass of aqueous MnXCl is lost due to splattering, the final mass of dry beaker and MnXCl will be decreased, and calculated mass and number of moles of Cl in dry solid will also be decreased. So the next question says another compound of manganese MnO2 is used in alkaline batteries, and which is represented by the following diagram. Some half reaction are given in the table. So based on the half reaction given in the table, write the balanced net ionic equation for the reaction that occurs for the reaction that has the greatest thermodynamic favorability. So first of all, what we need to do here, like we know one thing, the one which is having the more positive value, that would be considered as a cathode. So this one is having more positive value, so that is why it is going to be considered as cathode, which is having more positive value. And the one which is having the most negative value, that would be considered as anode. So this is going to be anode, because it has more negative value as compared to minus 0.76. So when we are going to write the net ionic equation, so we know that cathode is the one which is gaining electron. Reduction has been happening there, so it is gaining electrons. So I am going to write 2MnO2 in solid state plus water in liquid form, that is gaining 2 electron. Reduction has been happening there, and it is forming Mn2O3 solid plus 2OH minus in aqueous form. And anode is the one where oxidation has been taken place. So in the oxidation, the electron has been lost, and that is written on the right hand side. So here the electrons are on the left hand side. So we need to reverse this equation. So we are going to write Zn plus 2OH minus. We need to write the states as well. Zn is in solid, 2OH minus is in aqueous form, and they are forming ZnO in solid form plus water in liquid form plus 2 electrons. So what we are going to do, first we have to see whether the number of electrons that are gained and lost, they are same. So as they are same, so I am just going to add both of them. 2 electron, they would be cancelled. 2OH minus and 2H minus, as they are in the opposite side, so they would also be cancelled. And water molecule, they are also at the opposite side, so they would also be cancelled. So the remaining equation would become Zn solid plus 2MnO2 in solid state, and they are going to form ZnO in solid state plus Mn2O3 in solid form. So this is going to be net ionic equation. Calculate the value of E naught cell for the overall reaction. For E naught of cell, we have the formula E cathode minus E anode. So cathode is how much there? Cathode is this 0.15. Its value is 0.15 minus, that is going to be minus 1.28, and that comes out to be 1.43 volts. Now for the next part, we have to calculate delta G in kilojoules per mole. So the formula is minus N. F is the Faraday's constant times with the E naught of the cell. N is the number of electrons that has been lost or gained. So there are two electrons that is lost or gained. That is gained here and lost here. So we are going to write minus 2 mole of electron for 1 mole of reaction. Okay. And then what we can do here, we have to write for the Faraday's constant. So the value is going to be 1 mole of electron is having the charge of 96,485 coulomb, and then we have to multiply it with 1.43. This is volts. Volts are going to be written in joules per coulomb. Volts are written in joules per coulomb. And one thing, as you know, we have to convert it into kilojoules. So for that purpose, 1 kilojoules contain 1000 joules. So minus 2 here comes out to like 2 comes out to be the number of electrons. 1 mole of reaction contains 2 mole of electrons. 1 mole of electron contains 96,485 coulomb. 1.43 joules per coulomb is the this volts. Volts I have converted into joules per coulomb. And for E naught value, you know, it's in joules. We have to convert it into kilojoules. So 1 kilojoules contains 1000 joules. So the answer that comes out to be is minus 276 kilojoules and per mole of reaction. Next question says, a student claims that the total mass of an alkaline battery decreases as the battery operates because the anodes loses mass. Do you agree with the student's claim? Justify your answer. So they are saying that the mass of battery has been lost because anode is losing its mass, but there is no gas is forming here. No gas has been forming during the reaction. So first of all, there is no loss of mass has been taken place because as the battery is enclosed as well. So no change in total mass will occur. So what we are going to write, that the battery is enclosed. The battery is enclosed, and we can say one thing, so no change. So no change in the total mass will occur. How many grams? Next question is, in the gas phase, AlCl3 is a molecular substance. A reaction of gaseous AlCl3 at high temperature is represented by the following balanced equation. How many grams of chlorine can be formed from 1.25 mole of AlCl3? So here, if you can see that AlCl3 and chlorine is there, this is chlorine, this is AlCl3. So from equation 1:3 is there because that is forming 3 moles. And if there is going to be 1.25 moles of AlCl3, then that is going to be X. So X comes out to be 1.25 times 3. So that's going to be, answer is going to be How much? That is going to be 3.75 mole of Cl, but they want us to find the mass. So mass is going to be mole time molar mass, 3.75 times 35.45, and that comes out to be 133 grams of chloride. Then calculate the value of delta H1 in kilojoules per mole reaction for reaction 1 above using reaction 2, 3 and 4. So for this question, we have to find out delta H1 which is present in reaction 1. So we are going to apply Hess law here. So for reaction 1 is AlCl3 in gas state, and it is forming aluminium in gas state plus 3 chloride in gas state. So what we are going to do, like we have these equations, and this is representing enthalpy of formation because it is forming 1 mole of a compound from its elements. So elements I'm going to write here Al solid plus 3 by 2 Cl2 in gas form I'm going to write here, and I'm going to put it in a rectangle like this. This will also be in rectangle, and this will also be in rectangle. So you can see when 1 mole of a compound has been forming, it is going to have minus 583. So 1 mole of a compound is forming, so I am putting arrow from this point to this point. So that is going to be minus 583 because as it is forming 1 mole of aluminium chloride. Then aluminium in solid state is going to aluminium in gas state. So we have to put arrow from this solid to this point, and that is going to be plus 326. Now for chloride, you know it is Cl2 and it is forming 2Cl. Okay, but here we want 3Cl. So for that purpose, how can we put 3 here? By multiplying this one with 3 by 2. So if this is multiplied with 3 by 2, then that is also need to be multiplied with 3 by 2. In that case, you know, it was forming 2Cl, but we want 3Cl there. So 3 by 2, when we are multiplying it, then it will comes out to be 3Cl. So that's why we have to multiply its enthalpy with 3 by 2 as well, times with plus 243. And now the place from where all arrows have been initiating, that is going to be starting point, and the place where all arrows are ending, that is going to be ending point. So this is the place where all arrows are ending, that's going to be ending point. So from starting point we have two roots. One root is this one, this is root 1, and this is going to be root 2. So this is root 2, and then what you need to do, you are going to keep root 1 which is equal to root 2, and then root 1 we have only this energy, and then we have delta H1 here as well, which we need to find out. Minus 583 plus delta H1, and it is equal to 326 plus 3 by 2 times 243. So then what we need to do afterwards, we are going to keep delta H1 here, and 326 plus 583 and plus 1.5 times 243, and answer that comes out to be 1274 kilojoules per mole of reaction. In the next part, they are saying a potential energy diagram for Cl2 is shown in the following graph. So this is a potential energy diagram. So remember, that is going to show us the maximum energy. That is the point when two atoms, they have come very close to each other, that their nucleus and nucleus, as they are positively charged, they starts to repel each other. So here nucleus, they start to repel, and if they are repelling, the energy is going to be maximum. And this is a point where you can see that the atoms, they have made a bond, and they are going to be at the optimum distance. So that is basically the internuclear distance at which they have made a bond. And then this is going to be the point where the energy is zero. That is a point where the two atoms, they are away from each other. This is an important concept you need to remember. Based on the graph, what is the bond length in picometer for Cl2? So the bond length is going to be at this point where the energy is minimum, where it is having the proper internuclear distance. So that is going to be 200 picometer. Then a student find the average AlCl bond length in 220 picometer. And what is going to be the other thing? The other thing is going to be that that the bond energy is 425 at this point. The bond length is 220 picometer. Draw the potential energy curve for the average AlCl bond in the preceding diagram. So first of all, it is having the energy of 425. So 425 and 220 picometer, that lies somewhere to this place, at this place, okay, at this place. And when I'm going to draw a graph for them, how I'm going to draw a graph for them, like from this part, they are going to move towards this place like this, and from here it is going to move upwards towards this part. This, take this line straight, yes, like this. Three proposed Lewis diagram for AlCl3 gram molecules are shown. The AlCl3 gram molecules have trigonal planar geometry. Which diagram 1, 2 or 3 can be eliminated based on the geometry? And as they are having trigonal planar geometry, so trigonal planar geometry is going to be sp2. That means it is having 3 electron domains. So let's see which one is going to have 3 electron domain. That is going to be the right diagram. And the one which is not having 3 electron domains, that is going to be different. So if you see here, that is sp, sp2, 3 electron domains, that is absolutely fine. But if you see diagram 2, that is sp, sp2, this lone pair is representing sp3. So it is having sp3, which is not representing trigonal planar geometry, and this is also representing sp. Double bond is having sp2. So you can say one thing here, that diagram 2, why diagram 2, as aluminium has 4 electron domains, electron domains in diagram 2, which would be trigonal pyramidal, like NH3, not trigonal planar. So next question says, which of the three diagrams is the best representation for the bonding in AlCl3? Justify your choice based on formal charge. So first of all, we have to see these diagrams and we can find the formal charge. The formula for finding the formal charge is going to be, formal charge is equal to valence electron minus non-bonding electrons and minus bonding electrons divided by 2. So this V represents, so we have to find out the formal charge, and it represents, V represents valence electron, N represents non-bonding electrons, and B represent bonding electrons. So first we can find it for diagram 1. Diagram 1 is in which we can find out first for aluminium. Aluminium is valence electron of aluminium. It belongs from group 3, so having 3 electrons, minus non-bonding electron. If you see diagram 1, it doesn't have any non-bonding electron on aluminium because all the electrons have been bonded. So I'm going to write 0 at this point. Minus bonding electrons are how many? They are 6. 1, 2, 3, 4, 5, 6. So it is going to be 6 by 2 and that comes out to be 0. And in diagram 1 we have chlorine as well. We have to find its the formal charge as well. So chlorine is having the valence electrons which are 7 minus non-bonding electrons. How many non-bonding electrons in chlorine? We have 6 non-bonding electrons, because you can see 1, this 2, 3, 4 and 6. So we have 6 non-bonding electrons minus bonding electrons. We have 2 because this is 1, this is 2. So 2 by 2 and that comes out to be 0 as well. So diagram 1 is the one which is having a formal charge of 0. I have done for diagram 1. You can do it for diagram 2 and diagram 3 by yourself. So what we can write here, that diagram 1, what is the reason for diagram 1? Because all atoms in diagram 1 have a formal charge of 0, whereas atoms in diagram 2 and 3 have non-zero formal charges. Write the expression for the equilibrium constant Kp for this reaction. Kp is partial pressure of product is Al2Cl6, and P we have to write here like in the capital form, and at bottom we are going to write partial pressure of AlCl3, and there is going to be square because it is having 2 moles there. Now for the next part, they are saying a particle level diagram of an equilibrium mixture of AlCl3 in gas and Al2Cl6 in gas at 400 degrees Celsius in a 25-liter closed container is shown. Use the particle diagram. Calculate the value of Kp for the reaction if the total pressure in the container is 22.1. So how many AlCl3 are there? Let's see AlCl3 in the diagram. AlCl3 are 1, 2, 3, 4, 5, 6 and 7. So we have 7 AlCl3 and we have Al2Cl6 as 1, 2 and 3. So we have 3 of them. Use the particle level diagram, calculate the value of Kp if total pressure is this. So if we want to find out the partial pressure of AlCl3, that is 7 divided by total total number of particles, that are going to be 10. 7 plus 3 is 10 times with the total pressure, that is 22.1. So that comes out to be Kp is equal to there are 3 particles there of Al2Cl6. Al2Cl6 we have 3, so they are going to be 3 by 10 and times with 22.1, which is the total pressure. So 3 by 10 at the top times with 22.1 at bottom, that's going to be 7 by 10 times with 22.1, and that is going to be whole square. So value of Kp, that comes out to be 0.0277. So in this question they are saying write the balanced net ionic equation for the reaction. For balanced net ionic equation, we know that only aqueous forms are going to be converted into ions. So that is going to be calcium carbonate in solid state. This is aqueous form though, so that is going to be split up to hydrogen ions in aqueous form plus 2 chloride ions in aqueous form, and they are going to form this will also be split up, and that is going to form calcium plus 2 in aqueous form plus 2 chloride in aqueous form, and that is going to form CO2 in gas form plus water in liquid form. So that comes out to be like 2Cl minus 2Cl minus, they will be cancelled and the remaining is going to be net ionic equation. So that is going to be 2H positive in aqueous form, and that is going to form calcium plus 2 in aqueous form plus carbon dioxide in gas form plus water in liquid form. Question, they are saying a student performs an investigation to study factors that affect the rate of reaction. In each trial, the student combines 50 milliliter of HCl at 21.2 degrees Celsius with 1 gram of calcium carbonate and measures the time required for the reaction to go to completion. So they are saying the student correctly identifies that trial 5 is inconsistent with other trials. So if you see trial 5 and trial 6, then you are going to see one thing here, that it is having small chunks. Small chunks means that it is going to have greater surface area. Okay, greater surface area. So if it is having greater surface area, then its rate of reaction should be faster as compared to the large chunks which is having smaller surface area. But you can see a deviation in time of reaction. Its time of reaction, as it is having greater surface area, so greater rate of reaction, so time of reaction should be less. it should be less, but it is more as compared to this one. When it is having large chunks, then time of reaction is small, which needs to be larger. And when you see trial 1, 2, and you can also see one thing, that concentration of HCl are same in both of them. But when you see like trial 4 as well, which is having fine powder, and if it is having fine powder, then it is having the time of reaction which is very low, which is true. And if you see trial 1, 2 and 3, they have the same concentration, and you can see they goes according to the right thing, that having the small particles would be having greater surface area and the greater rate of reaction, so time of reaction is low. So how I am going to write it? So this is going to be the right explanation for it. Let's move towards the next question. So they are saying, based on the conditions and collisions, explain the reason for the difference in reaction times for trial 2 and trial 3. So trial 2 and trial 3, if you see, then one is having smaller chunks, which is having greater surface area. So if it is having greater surface area, what we mean by that, it is having greater surface area, so its rate of reaction would be high. So rate of reaction would be high in trial 2 as compared to trial 3, because it is having smaller chunks, having greater surface area, so the rate of reaction will be higher. So how we can write here that the time of reaction, so the time of reaction in trial 2 is shorter than trial 3, because the calcium carbonate in trial 2 has greater surface area, so rate of reaction is faster and time for reaction is lower. So in the next question, the student claims that the reaction is zero order with respect to HCl. Do you agree or disagree with the student claim? So if we see that if we let's compare, like both are having fine powder, and the concentration is in of HCl is increasing by 3 times, and the time of reaction, time of reaction, and first the rate of reaction and time of reaction, they are inversely proportional. First of all, this is very important thing. And what we can see here, if it is increasing, concentration is increasing 3 times, then it is going to become 1 by 3 times. Like 67 is going to become 22, so that is becoming 1 by 3 times time of reaction. That means rate of reaction has become 3 times. That means rate of reaction has become 3 times. So when you are increasing the concentration of HCl by 3 times, time of reaction has decreased by 1 by third time, and the rate of reaction increased by 3 times. Rate of reaction increase by 3 times. So what happens, which is going to be the rate of reaction? That is going to be first order reaction. So rate of reaction increased by 3 times, and as concentration increased by 3 times, rate of reaction also increased by 3 times. So we can say it is going to be first order reaction. So how can we write the explanation that we are going to disagree with the claim? How? So this is going to be the right explanation, that we disagree. The reaction appears to be first order, not zero order with respect to HCl, because when we are tripling HCl concentration, this result in the reaction time decreased to 1 by 3, which means the reaction rate has also tripled. So in this question, they are saying the HCl was present in excess in all trial of the experiment. Determine the molarity of HCl in the beaker after the reaction is complete in trial 2. Assume that the volume of the mixture remains constant at 50 milliliter throughout the trial. Molar mass of calcium carbonate is 100.09. So first of all, we need to find out the initial moles. So if we are going to find the initial moles, we know that the it is having the volume of HCl is having the volume of 50 milliliter, and as we want to find it in trial 2, so trial 2 is having the concentration of 1 mole per liter and volume is 50 milliliter of HCl. So if we want to calculate initial moles, that comes out to be, concentration times volume. Concentration is 1 mole per liter and volume is 50 milliliters, so we can convert it into liter, 0.05 liter. So that comes out to be 0.05 moles. These are initial moles. Now we have to find out how many moles have reacted. So calcium carbonate here is 1 gram calcium carbonate that has been given to you, and from calcium carbonate you can find the number of moles. Mole of calcium carbonate, that comes out to be mass, which is 1 gram over molar mass, which is 100.09, and it comes out to be how much? That is around 1 by 100.09. So as we know that 1 mole of calcium carbonate are combining with 2 mole of HCl, so they are having 1:2 calcium carbonate with HCl. So as they are having 1:2, so if it is going to be 0.0099, so that comes out to be like 0.02 mole of HCl, which has been reacted. That is reacted, and they are initial moles. So how many moles of HCl which has been left? Mole of HCl left. Initial moles, which are 0.05, minus reacted moles, that are 0.02, that comes out to be how much? 0.03 mole of HCl. Now we have find out the moles, but we need to find out the concentration in 50 milliliter. So now if we want to find out concentration, that is equal to mole per volume. Mole is how much? 0.03 and volume is 0.05. So the final answer that comes out to be 0.6 molarity. So next question says, in order to measure the enthalpy of reaction, the student repeats trial 1 by mixing 50 milliliter of HCl with 1 gram of calcium carbonate using a coffee cup calorimeter. The student records the temperature of the system every 20 seconds. Is the reaction endothermic or exothermic? You can see that as the temperature of the solution is increasing, so it is going to be exothermic because the temperature of the solution is increasing. We can write the solution temperature increases, solution temperature increase as reaction proceeds. Calculate the magnitude of heat transfer Q. So you have to find out the Q, which is formula is mc delta T. Mass is how much? Mass is going to be 51 gram times with specific heat capacity, which is 4.0, and delta T is the temperature. So you can see final temperature is this one. This is final temperature, and that is going to be initial temperature. So final temperature minus initial temperature, it comes out to be 21.90 minus 21.20, and Q comes out to be 140 joules. So we have to find out enthalpy. Enthalpy is equal to minus Q over N, Why we are putting minus sign? Because it is exo, and minus q is minus 140. Okay, and minus 40, but for q we need it is in joules. We have to convert it into kilojoules because they want answer in kilojoules per mole. So divided by 1000, that comes out to be minus 0.14 kilojoule. And then you have to find out the mole of calcium carbonate. Mass is 1, calcium carbonate is 100.09, so it comes out to be 0.00999 mole. So now delta H is equal to negative Q of by N. Negative Q is minus 0.14 over N is 0.00999, and it comes out to be minus 14 kilojoules per mole. So next question says a student is asked to prepare a buffer solution made with equimolar amounts of CH3NH2 and CH3NH3Cl. The student uses 25 milliliter of 0.1 molar CH3NH2, and now they are saying us that we need to calculate the mass of CH3NH3Cl that contains 0.00250 mole of CH3NH3Cl. So we have moles, and for mass is equal to mole times mr. Mole is 0.00250, and mr of CH3NH3Cl is going to be 67.52. So our answer that comes out to be 0.169 grams. ये आपसे था So for the next process, you are going to use the balance to measure the weight of 0.169 gram of solid. Let's move further. Now in this part, you can write this one like exactly the same in step 1, but for this step, what we need to write here, we are going to write, as we are going to put uh, the other solution CH3NH2 in the burette. So what we need to do, we are going to first rinse the burette with small amount of the same concentration of CH3NH2 solution. So how can we write it? So this question is saying us in the C part, they are saying that pH of the buffer the student prepared is 10.64, and the student prepare a second buffer solution. The student uses 25 milliliter of 0.050 molar CH3NH2 instead of 25 milliliter, and half the mass of CH3NH3Cl. Now, before in the first part, as they are saying, like if we want to calculate pH, then that is equal to pK, like for the first buffer. If we see for the first buffer, then for the first buffer we are going to do POH, which is equal to pKb plus log of concentration of salt to that of acid. So salt here is going to be how much? The salt here is going to be the base here, and that is going to be the acid. So if you can see the base here, base is having this much, and if you see its number of moles, you can multiply molarity with the volume, and that comes out to be 0.0025. And here the moles are also same because they are equimolar amount, so that is 0.0025. So you can see that POH that comes out to be also that is going to be equal to pKb. Because why pKb? Because the that is equal to this one because their number of moles are same. So log of 1, that comes out to be 0, so POH comes out to be equal to pKb. And here in the same way, what happens, like when you are trying to find pH, which the formula is going to be equal to pKa plus log of base, or you can say salt over acid. And you can see here what they are saying, the number of moles are halved. Like right now they are using this much, so the number of moles of CH3NH2 is going to be 0.00125, and as the moles of CH3NH3Cl are half, and as they are equimoles, and before they were having 0.0025, now they become also 0.00125. So again you can see one thing, that pH is equal to pKa, because the moles remains constant, they are constant. So pH also remains equal to pKa, and we can say that the pH of buffer actually depends upon the ratio of base to acid. So we can write here that there is going to be no change. We can write that it is going to be equal to the ratio of equal to as the ratio of weak acid to base is still 1:1. So that is why there is going to be no change. So in this question, they want us to calculate the number of moles of HCl. We are given with the liters, pressure and temperature. Formula is N is equal to PV by RT. Putting the values there, pressure is 7.45 atm, volume is 6 liter, and R is going to be 0.08206 liter atm per mole per Kelvin, times with 296 Kelvin, and number of moles that comes out to be 1.84 mole. So in the next question they are saying that the rigid 6 liter container of HCl is cooled to temperature of 271 Kelvin. Calculate the new pressure. So we are going to use the formula P1 by T1 is equal to P2 by T2. And as you know, we need to find new pressure. So P2 is equal to P1 by T1 times with T2. P1, pressure 1 is, we have pressure 1 is going to be 7.45 atm. That was given to us. This is P1, initial pressure, and that is initial temperature, that is T1. And T2 is going to be this one, which is the final temperature, times with T2, that is 271 Kelvin. And then we can do temperature. Temperature is how much? T1 is going to be 296 Kelvin, and the answer that comes out to be 6.82 atm. You can even use that formula, P is equal to nRT divided by V. N is the number of moles. You can find out N, which is the number of moles we have already found, that is 1.84, 0.08206. Temperature nu is going to be 271, and liter is 6 liter there. So you have the same answer. So in this question they are saying when HCl ionize in aqueous solution, ions are formed. So what happens, like HCl, they ionize in water, they are going to form H positive plus chloride ion. Okay, aqueous form and aqueous form. Now what happens there, like this aqueous needs to be written here. because it is a strong acid, so it completely ionizes in water. And what happens, hydrogen ions being positive charged over there, that is going to be surrounded with oxygen molecules, like this. But now they have given us chloride ions which are having a negative charge, so that is having the force of attraction like this one. And chloride ions, they are going to be surrounded with hydrogen ion. So water is represented in this way there. So we can write one orientation at this point. This is oxygen, this is hydrogen that is pointed towards chlorine, and we have another oxygen with hydrogen that has been pointed like this. We have another oxygen and with hydrogen that has been pointed like this. So in this question they are saying the following particulate diagram represent the ionization of one of the acid in the data table. These are the acids and these are their Ka values. So they are saying, after seeing the diagram, identify which acid it could be. So if we see one thing, like Ha is an acid, and when it ionizes, it is going to form H positive plus A minus, which is an anion. So if we see this diagram, we are saying one thing, that Ha is an acid, so most of them are present in acidic form. They have not completely ionized in hydrogen. Like hydrogen ion has not been released properly, so that is Ha, like 1 2 3 4 5 6 7. So only one hydrogen ion has been ionized. Hydrogen ion here is represented with H3O positive. So we can see one thing, that most of the acid is present in unionized form. That indicates that this is going to be a weak acid. So weak acid are going to have the Ka value which is going to be less than 1. So which is going to have the Ka value to be less than 1? That is going to be HNO2. That represents this weak acid. So we can write the explanation like this. So as it is evident from the diagram that most of the acid were weak acid, as most of them are present in unionized form, so we are going to say that is going to be weak acid with Ka value that is less than 1. So answer is going to be HNO2. So they are saying in the following table, list all the type of intermolecular force present in pure sample of HBr and HF. HBr is having two type of forces, that is London dispersion forces, London dispersion force, and as you know it's a polar molecule, so it is also having dipole-dipole interaction, because bromide is more electronegative than hydrogen, so dipole-dipole interaction as well. But here if you see HF, then the both forces are present in them, London dispersion, also dipole-dipole. But there is one more force that is also present in them, because we know there is a special type of force when hydrogen is bonded to most electronegative element, that it could be nitrogen, that could be fluorine, that could be oxygen. So London dispersion force, dipole-dipole, and hydrogen bonding, this special type of force is called as hydrogen bonding because fluorine is present there. So that's going to be hydrogen bonding as well. Now they are saying, based on the type and relative strength of intermolecular force, explain why enthalpy of vaporization means you are giving more energy to HF as compared to HBr. And the reason is the same, that there is a special type of force which is hydrogen bonding that is present among them, which makes the enthalpy of vaporization to be quite higher. So this is the right explanation, that due to the presence of hydrogen bonding in HF, it's going to have higher enthalpy of vaporization. So the next question is saying calculate the amount of thermal energy required to vaporize 6.85 grams of HF. So they have given us the enthalpy of vaporization, and if we want to calculate the thermal energy, what we need to do, we know we have a formula that is going to be delta H is equal to Q by N. So if we want to find Q, then enthalpy of vaporization are going to be multiplied with the number of moles. Enthalpy of vaporization is 25.2 kilojoule per mole, and the moles of HF, mass over MR, that is going to be 6.85. MR of HF is going to be 20.01. So we are going to multiply 6.85 by 20.01, which are the number of moles, and the answer that comes out to be 8.63 kilojoules. So based on the arrangement of electrons in the bromine and fluorine, explain why the bond strength in an HBr molecule is greater than that of HF molecule. Why the bond length is greater. So you are going to see one thing, that bromine is having 4 shell, while fluorine is having 2 shell. So you can see one thing, that extra electron shell in bromine that increase the distance between hydrogen and bromine nuclei, giving HBr the greater bond length. How can we describe this thing? So as we can say that as bromine is having 4 shells, fluorine is having 2 shells. So because of the extra shells in bromine, it increased the distance between hydrogen and bromine nuclei, giving HBr the greater bond length as compared to hydrogen fluoride. Strontium hydroxide dissolve in water. According to the following equation, the Ksp expression of strontium hydroxide is provided. You can see strontium here is going to be 4, and hydroxide here is going to be how much? That is going to be 1, 2, 3, 4. So both are 4. But if you see they have the ratio 1:2, then you can say one thing. A student draws the particulate diagram, and they are saying identify the error in student's drawing. So as you can see, according to equation, there is 1:2, but in the diagram they are showing 4:4, like 1:1. So you can say one thing, that the student's drawing shows an incorrect ratio. Student's drawing shows an incorrect ratio and between strontium ion and hydroxide ion. So in the next part, they want us to calculate the concentration of hydroxide ion, and they have already given us the concentration of strontium ion, and you can see that they have 1:2. So this is strontium ion, these are hydroxide ion, and from equation they are 1:2. So if it is 0.043, then it is going to be x, and x comes out to be, you are going to multiply them both, so that comes out to be 0.086 molarity. Then if we want to find out the value of Ksp, which is equal to strontium plus 2 hydroxide ion whole square. Strontium ion here is going to be 0.043, which is given to us, and hydroxide ion we have calculated, that comes out to be 0.086 whole square. So that comes out to be 3.2 times 10 to the power minus 4. This is the value of Ksp. Now they are saying the student prepares a second saturated solution of strontium hydroxide. Strontium hydroxide, when dissolves, it is going to form strontium ion Sr plus 2 OH minus. And when they are preparing in this solution instead of water, then it also contains strontium ion and 2 nitrate ion. So you can see one thing, because of the common ion effect, they are common, it increased the quantity of strontium ion there, which caused the equilibrium to move towards left hand side and caused the quantity of OH ion to decrease. So how can we write it? That it is going to be less than. Why it is going to be less than? Because the strontium nitrate aqueous solution already contains a common ion, which is strontium ion. The solubility of strontium hydroxide decrease, and also decrease OH ion concentration. Okay, that's all from this 2023 paper. Thank you so much for watching.